Find the measure of the arc or central angle indicated. Assume that the lines that appear to be diameters are actually diameters. So someone with a raised hand, can you tell me one of the diameters in number 13? Tyler?
MJ.
MJ? What is the other diameter? Kerwin?
What, IL?
Yep, IL. Alright, so diameters cut the circle completely in half. So you can do this a couple different ways. What relationship do these two angles have together?
Congruent.
They're congruent. Why? What's their relationship? Yeah, vertical angles. So because the arc is 41, that means the angle is 41, which means this one's 41, which means this one's 41. So you can use either diameter, but here's how it works. An arc that starts and ends on the diameter, that is called a semicircle, and they add up to 180 degrees. You have 41 and 89 degrees of it. So how could you find the third piece? Add and subtract from 180. If you use that diameter, that would work. If you use the other diameter, IL, you would do the same exact thing. You have 41 and 89, which add up to 130. So take from 180, 180 minus 130 is 50 degrees. Questions on that one?
What did we define?
We found the measure of arc LK. We used their diameter and the two arcs that were already given of the diameter. Number 14 says find the measure of an angle SRT. So you're finding this angle. All right. Do you know the measure of the angle that's directly next to it? Yes, what is it? 114. When you take these two and put these two together, they sit on the diameter. How many degrees? And diameter is a straight line. How many degrees is a straight line? 180. So what can we do to find the measure of our angle? Subtract from 180, yep. So 180 minus 114 is 66. Questions? Comments? Alright, it is. So we're going into 10.4. It's called Inscribed Angles and Polygons. You're going to learn about inscribed angles, and you're going to learn about inscribed polygons. Didn't mean to get squeaky. Alright, so the first thing that you're going to learn, you're going to flip through your notes, go to inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain the chords of the circle. Alright, so the main thing that you want to highlight if you have a highlighter is that the vertex is on the circle. So that little phrase, vertex is on the circle. Alright, so an arc is created by this angle, and the arc that lies between the two lines, rays, or segments is called the intercepted arc, and that's highlighted in blue on my screen. If the endpoints of a chord or a line, or an arc, lie on the sides of an inscribed angle, then the chord or an arc is said to be a subtend the angle. The main important thing is that inscribed angles, the vertex is on the side of the circle. Alright, so it could be to the left like it is now. The vertex could be down here, could be to the right, could be up. Just that the vertex is on the circle in general. Alright, so we are going to learn about it. This is not necessarily the next thing in your notes. It is in your notes somewhere. You see the theorem on the screen. I'm going to have you write down a phrase about inscribed angles. Inscribed angles are not congruent to their arcs, but here's what they are. The inscribed angle is half of the arc, and the arc is double the angle. I need you to write that down. I know, you're going to write it the way that I have it. The angle is half the arc is double the angle. So you're writing it down.
Marshall.
Yes, ma'am.
Can I have Kobe Brown for a minute, please?
Yes, ma'am.
Thanks.
So the angle is going to be half of the arc, and the arc is double of the angle. As long as you can do those two things, you can do inscribed angles like nobody's business. But here's the thing. It's simple and it's easy, but when you get to the test, if you don't look over this before the test, you're going to do inscribed angles when it's a central angle, and a central angle when it's an inscribed angle. So make sure that you can tell the difference between the two. The main difference between the two is the way that they look. This is on your notes, so if you flip backwards a page. Yep. You need to be able to see the difference. A central angle, they are congruent to their arc. But the main thing, in order to visualize it, to see it, the vertex of a central angle is on the center. That's not written on your notes, so you want to write that. For a central angle, what makes it central is that the vertex is on the center of the circle. There you go, right there. Do you have today's notes? Because that's yesterday's notes, or 2 days ago's. All right, in an inscribed angle, they are half of their arc, but also the vertex is on the circle, any part of the circle. And in the next section, we are going to decide if we have an inscribed angle, a central angle, or neither. All right, so I numbered them on my screen, 1, 2, 3, 4. Yours are not numbered, but number 1's on the top left. Where is the vertex? In the center. So what kind of arc is this? Or what kind of angle is this? Central. So you should write central. It says then name the intercepted arc. The intercepted arc is the arc made by the two rays of the angle. So you name an arc with a little rainbow thing, and then the letters J, K. Number 2, where is the vertex? On the circle. So what kind of angle is this? Inscribed. It is inscribed. All right, and it creates this intercepted arc of GF. Number 3, where is the vertex? Is it in the center, on the side, or neither? On the side, which makes it what kind of angle? An inscribed angle. Don't make me start calling people out. What would the arc that is intercepted, what would that be named? Yeah, arc XW. Number 4. Where is the vertex? On neither. It's not on the center, it's not on the side, so it is neither. So we had a central angle, an inscribed angle, and an inscribed angle, and then neither. All right, so we're going to do some practice problems. There's a problem just like this on your test. We're going to find the indicated measure. So, the first part's easy. It says find angle T, the measure of angle T. What arc, give me the 2 letters, of the arc that are the intercepted arc of angle T? RS. All right, so the arc is double the angle. The angle is half the arc. So what is the measure of angle T? 24 degrees. The second portion, there's 2 steps to it. It asks me for the measure of what arc? QR. QR does not have an angle that it is directly across. But if you don't have an angle that is directly across, here's what you can look for. Is there a diameter? What's the diameter called here? Yeah, TR, RT. All right, so a diameter cuts a circle completely in half. If you were to look at the arc from one end of the diameter to the other, I highlighted it in red, that's 180 degrees. So what you can do, if all of the arc is 180 degrees, you can figure out what TQ is, and then you would be able to figure out what QR is. What is the measure of TQ? 100. The arc is double the angle is half the arc. So now look, when we have a semicircle that starts and ends on the endpoints of the diameter, that's 180 degrees. So what is left for QR to measure? 80, because 180 minus 100 is 80 degrees. We're going to do another one very similar to it. All right, we're going to do these three. Find the measure of angle K. Angle K corresponds with the arc of JL. The angle is half of the arc. So what's the measure of angle K? 20. Number 2, find the measure of arc DF. Arc DF corresponds with angle E, which is 72 degrees. The angle is half the arc. The arc is double the angle. So what's the measure of arc DF? 144. All right, and this last one is just like the one that we just did. It asks for the measure of arc ST. All right, but we have no relation to ST. There's no angle in comparison to ST. So here's what we can do. Do you see a diameter? Yes. What's the name of the diameter? SU. All right, so that means from STU on both sides, that's how many degrees? 180. We can figure out this piece because it corresponds with the inscribed angle of 61. So what is the measure of TU? Nope. 122. You double it. Remember that the arc is double the angle. All right, so now we have 122 degrees of the 180 of the semicircle. So how do we find ST? Subtract from 180. So 180 minus 122. 7, so we get 58 degrees. Put it away. In summary, an inscribed angle is half the arc. This is moving with your notes. Is half the arc. The intercepted arc is double the inscribed angle. And then the last thing that you'll write on that page is that central angles are congruent to their arc. Yes, dear.
So it's on the inside. We multiply by 2 and multiply by outside.
Divide by 2. All right. So now we're going to do 2 more and then move into the last 2 aspects of 10.4. All right, so find the degree measure of the arc or angle indicated. We're finding an arc here. Finding LM. LM is an arc. What is the angle that it corresponds with? 56. All right, so you're given the angle, so how do you find the arc? Multiply it times 2. What's 56 times 2? Degrees. The next one, we're finding the angle. What arc does it correspond with? ZY. All right, so we have the arc. So instead of multiplying by 2, divide by 2. So you get 41. So we're actually going to flip back to this in like 2 seconds. You can stay on that paper. You should have a right triangle on that paper. Should look like this. So I'm going to tell you the gist of this theorem. If a triangle's side is the diameter, then it's a right triangle. Okay, and that side that is the diameter, that's going to be the hypotenuse. So looking at these two pictures that we literally just did, they're at the bottom. They're at the bottom of your paper. Is number one, or this problem on the left, is that a right triangle? Yes, it is. Why is it a right triangle? What did our theorem? Because a diameter is one of the sides. So you guys just proved you need to write this down, because half of you didn't even look at it. If a triangle side is a diameter, it's a right triangle. So you need to write that down. It's on your paper in fancy lingo that you're not going to read. I already know you. If a triangle side is a diameter, then it is a right triangle. And that means the diameter is going to be the hypotenuse. Because the diameter is the longest side, or longest portion of the entire circle. Alright, so if a triangle side is a diameter, then it is a right triangle. So, back to what I was asking you. On the left, is this a right triangle? Yes, it is. So it's a right triangle. And where is the hypotenuse? Name it. MK. Which would make what the angle that's 90? L. That is important because you're literally going to have a problem on your test and quiz that will set up like this. On the second, is that a right triangle? No, why not? There is no diameter. The side is not the diameter. Diameters go straight through the center of the circle, and this one does not. All right, so we're going to use this on the next page, or however many pages away. This is from your student journal. All right, so we have a diameter of BC. So this is my hypotenuse. BC is my hypotenuse. So where is my right angle?
A.
Angle A is my right angle. So the very first question, first question says find the measure of angle A. So that would make it 90. Find the measure of angle C. So you already have 90 degrees. Angle B is 28, so you can do one of two things. Add 90 and 28, subtract from 180. Or, how many degrees does angle B and C have to add up to? 90. So you can do 90 minus 28. So we got 62. So the measure of angle C is 62. Find the measure of BC. That's a side, correct? So we need to find BC. Were we given two other sides? We weren't. We were. 7.3 is the measure of AB. 3.9 is the measure of AC. How do you find the third side in a right triangle? The Pythagorean theorem. So you're going to do this on your paper. I'm not. Are we missing A, B, or C in the Pythagorean theorem? C. So you guys are doing this on your paper. Alright, so what's 7.3 squared plus 3.9 squared? It's like 86 point something. Oh, 68. Equals C squared. So is this what C equals? No. So what do you do next, Lucius? Take the square root of it. Round to the nearest tenth, and you get 8.3 equals C. 8.3. All right, after that, we're finding the measure of arcs. We need to find the measure of arc AC. What angle corresponds with arc AC? B, which is 28 degrees. So what's the measure of AC going to be? 56. You're okay. You double the angle to get the arc, so 56. And then last, find the measure of arc AB. What angle corresponds with that? C, which is 62. It's written on my board. All right, so we gonna half it or double it? Double it. So what's double of 62? 124. Boom. Yep. Now we have one last thing to talk about. It's about quadrilaterals. What is a quadrilateral? A four-sided figure. Thank you. Perfect. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. I need you to highlight the word supplementary because most of you are going to forget in the next 2 seconds. Supplementary. Does it say the word congruent? No, it says the word supplementary. What does supplementary mean? They add up to 180. So D and F in our picture, they add up to 180. E and G, they add up to 180. This should be a very simple process, but if you do not learn that they are supplementary, you're just going to get silly points wrong. We have a couple more examples here. We have A and B. What kind of shape is A? A what? A right triangle. What makes it right? Because it's on the diameter. So, where's the right angle? Where 2x is. This is literally identical to a problem that is on your test. And most people, by the time they get there, they'll forget this. 2x is going to equal 90. So, what's x? 45. That's all you do. Doesn't say anything more difficult. Letter B. What kind of shape do we have? Quadrilateral. So let's say we wanted to find Z first. Z is across from what angle? Angle F, which is 80 degrees. So that means they have to be supplementary. So how do I figure out what Z is? 180 minus 80, right? Is 100. So Z equals 100. That's all you do. The next one, y and 120 would be 60. Here's the other way to look at it. These two have to add up and equal 180. The reason I write it like this, it's not always going to be a one variable. It might say 2y or 3z minus 1 or something like that. Subtract from 180, y equals 60. Alright? We got two more together. Letter P. What is the easiest angle to find on this picture? Y. What is the measure of y going to be? 90. Alright, and then X. What is 180 minus 81? 99. The second, a lot of people get wrong. 63 is across from what angle? 3x. So what would I do to solve for x? Nope. Do they equal each other? No. Add them and set them equal to 180. 63 plus 3x equals 180. Subtract 63. In mi casa. Equals 117. X equals 39. So the other option. Y is what? Well, 3 goes into 11 3 times.
I said I want the wrong part.
Oh, you're fine. Yeah. He did the next one. So listen, there are two ways to do this. This was one of them. If you're not good at math and not good at remembering, you should do this way. The second way to do it, what does 3x equal if the angle opposite of it is 63? What's 180 minus 63? We literally just did it. What's 180 minus 63? 117. So you could do that in your calculator and set this equal to 117 because you know it will equal 117. Using that same philosophy, angle B is 65. So what does angle D equal? What's 180 minus 65? 115. So you could do that. Or you could do the same thing. 4y minus 1 plus 65, because they're opposites, they add up and equal 180. Either way, you're going to get the same answer. Minus 1 plus 65 is 64. Subtract 64, divide by 4, y equals 29. So either way you had done it, the one in blue or in green, you would have gotten the same exact answer. Alright, you're going to do the last problem. It's on the last page. And then you're going to do some classwork.
You said classwork or crosswork?
Classwork.